So topic 2.1 to 2.3. So a very small pollen grains are suspended in a water. A bright light is shined from the side. When looked through a microscope, a small speck of a light are seen moving random in a jerky manner. What is the reason for that? Look, whenever we have a dust particle or we have pollen grains, like if dust or a smoke particle, dust and smoke particles are there in air. So these dust and smoke particles are continuously colliding with the lighter air molecules, and that cause a random motion. Same thing if we have a pollen grain which is there in water. So there are water molecules. Water molecules are not visible. We can see the pollen grains. So we can see these pollen grains that is visible to us, but water molecules cannot be seen by a naked eye. So as a result, when these water molecules hit the pollen grain, these pollen grains will move randomly. They will change the direction, which we call a Brownian motion. So what are the moving specks of the light? Like basically, what are the moving specks of the light? These specks of a light, because what happened? The light strike the pollen grain and we receive that light from the pollen grain. So actually these are the pollen grains, and these pollen grains, because they are continuously colliding with the lighter water molecules which cannot be seen or visible to the naked eye, so it appears that the light speck is moving in a jerky manner. So pollen grains hit by a water molecules, that is why we observe this random motion. If the same can be done, if there was a smoke particle, like there was a container which was filled with smoke particles and we'll shine a light, we'll also observe the same random motion, and that time the random motion will be the dust particles or a smoke particles which are colliding with the air molecules. So for this one, B is the right answer. In question 2, at minus 39, the liquid mercury solidified without changing a temperature. Remember, whenever there is a change in state, there is no change in temperature because the energy is used to either break the bond or form the bond. Which row shows whether a mercury absorb or release energy? It will absorb energy. The energy will be absorbed when a solid convert into liquid and a liquid turn into a gas. This is the change in which the energy is absorbed. And energy will be released when a gas turned into a liquid or a liquid turned into solid. So in this question, because the liquid mercury solidified, so liquid is turning into a gas. So whenever a liquid is turning into a solid. So when liquid changes into solid, what will happen? The energy must be released. So either C can be an answer or D. Then because the liquid changed to solid, the solid will have a strong bond as compared to that of a liquid. So what happened to the bond between the atom? They will get stronger. So C is the right answer for this. In question 3, a model thermometer. So this is a model thermometer, like this is a bulb of a thermometer. And this one is a capillary or a bore. A model thermometer consists of a flask of a colored water and a stopper is there. A model thermometer can be changed in two ways. So we can change this model thermometer. The flask can be replaced by a large one full of colored water. So if we increase the size of the flask, what will happen? It will make it more sensitive, because the sensitivity is affected by two things. The sensitivity of a thermometer can be affected by a large bulb and narrow capillary. So if we use a large bulb, this what it will do, it will make it more sensitive. The glass bulb can be replaced by the one with a large internal diameter. So the glass tube can be replaced with the one with a large internal diameter. So if we increase the diameter, the size of the capillary, what will happen, how it will affect, it will reduce the sensitivity. Because if the capillary is having a large area, then the sensitivity of a thermometer will decrease. So what it will do, it will make it less sensitive. So which statement is correct? So only using a large flask increase the sensitivity. So that is true. A is the right answer. Because when we use a large flask or a large bulb, it will have a greater volume of a liquid. When we have a greater volume of a liquid, so it will have a greater sensitivity as well. So A should be the right answer for this. In question 4, a metal has a specific heat capacity of 360 joule per kilogram degree centigrade. An object made from this metal has a mass of 2 kilograms. What is the thermal capacity? So the formula, look, there are two formulas to calculate a thermal capacity. Thermal capacity is energy divided by change in temperature. That is one. Or the other formula for thermal capacity.
By C.
Yeah, the second formula which we can use for the thermal capacity, that is the mass multiplied by specific heat capacity. So M into C will also give thermal capacity. So there are two formulas. Thermal capacity is energy divided by change in temperature, or mass into specific heat capacity. So specific heat capacity is given 360, and the mass, it's also in kilogram, which is 2. So 360 multiplied by 2, that is equals to 720. So it is joules, 720 joules per degree centigrade. In which type of a substance are free electron involved in a transfer? Because not all of the materials contain the free electrons. The free electrons that are present in the structure of a metal, because the structure of a metal consists of a lattice of a positive ions, the cations, and the delocalized electron. Not all the metal, like example, when you see a piece of wood, glass, they don't contain any free electrons. Their electrons are bonded. They have a molecular structure, a giant or a macro, but they don't have free electrons. So which substance are the free electrons involved in transfer of energy? So that is metals only. Because all solid does not have the free electrons. They have electrons, but the electrons are not free, such as like plastic, wood, glass. They all are solid, but you don't find their free electron is there present in the structure. In question 6, 4 objects which are made from same material, they have the same mass and they have the same temperature. The object have different surface areas and different the objects have different surfaces and different surface areas. Which object emit the infrared with the greatest rate? Look, the rate of emission of a infrared depends on what? It depends on the temperature. More the radiation, infrared radiation increases if the temperature increase. Infrared radiation increase if the object is large surface area. And amount of infrared radiation will increase if the object is dull or dark, because dull and dark surfaces are good absorber and good emitter. So the surface should be dull and the surface area should be large so that it will emit out the maximum amount of heat radiations. If you want me to repeat any question, just let me know. I will repeat that question. Like if any question you're not able to understand. In question 7, a cylinder with a tap containing a fixed mass of a gas X. So there's a gas X is present. The gas container, the gas is contained by a piston which can move freely towards and away from the tap. So when the tap is open, the piston moves slightly to the right. Like here, this is the initial position, but when we open the tap, the piston moves slightly towards the right. So what does it show? It shows the pressure of the gas before we open, and then it stops. So what it shows that this gas initially, when the tap is moving, like this was the position of a tap. So this is the position of the tap. Once we, this is the position of the piston. And once we open the tap here, so when this part is open, what we observe the piston move towards the right hand side and stop. So what it shows that the pressure of the gas was higher initially. That's why the tap, when we open the tap, the piston moved towards the right hand side, because on the right hand side, towards the right hand side, the gas is exerting pressure, and towards the left hand side, the atmosphere is exerting pressure. Because the gas is exerting more pressure, that's why the tap, when we open the tap, the piston moves towards the right hand side, and the piston will move, and then it will stop. So when it will stop, what does it mean? Now the pressure of the atmosphere and the pressure of the gas is balanced. So what can be deduced about the pressure of a gas before opening the tap? So it means the pressure was higher. That's why the moment we open the tap, the gas pushes the piston towards the right hand side, and it pushes the piston toward the right hand side. As the volume is increasing, the volume of the gas increases, so the pressure exerted by the gas decreases. And as a result, when the pressure exerted by the gas decreases, eventually the outside pressure will balance with the inside pressure, and the piston will stop moving. So after opening, the pressure will be same as the atmosphere, but before opening, the pressure of the gas was higher, or at the moment we open, that the pressure was higher. So that's why D is the right answer.
Mr. Sorry, in question 6, it was A, yes?
Question 6. Yes, it was it.
Yes, okay, it's there. Thank you.
In question 8, liquid evaporates from a beaker. What happened to a temperature of a remaining liquid, and how this temperature change affect the rate of evaporation? Look, whenever evaporation occurs, the most energetic molecules at the surface will escape. So and they gain energy from the surroundings, from their neighbors. Say example, this liquid was at 30 degrees centigrade. Example, the most energetic molecules which are there at the surface, they gain energy from the surrounding and they escape. So what happened to the liquid which is left behind? It will have a low temperature, and the evaporation depends on the temperature as well. At higher temperature, the liquid evaporates faster. At lower temperature, liquid evaporates slower. So now the temperature is 28. Now evaporation will also occur, but the rate at which, or the speed at which the evaporation happen or occur at 28 will be much slower as compared to that of 30. So what happened to a temperature of a remaining liquid, the liquid which is left behind, that temperature will decrease. And what happened to rate of evaporation? Because the temperature decrease, so rate of evaporation will also decrease. So at high temperature, liquid evaporate faster, but at low temperature, the liquid evaporate at a slower rate. Which quantity does not change when there is an increase in temperature? So temperature cannot affect the amount of the matter. Density will change because density is mass present in a unit volume. If we increase the temperature, the substance expand, the volume increase, so density decrease. Diameter also, because the volume increase, so the diameter will also increase, change. Length, the substance, when we increase the temperature, it expands. But the amount of the matter, the mass does not change. Why? Because mass is the amount of matter, So when we supply energy, the particle will move faster, but the number of the particle within the material does not change. That's why D is the right answer. A thermocouple is used to measure the temperature. So what is the advantage of using a thermocouple? A thermocouple can measure the advantage. It can measure a rapid change in temperature, a very fast change in temperature. So a thermocouple measure temperature, the most effective advantage, because it is consisting of the metal. Metal are good conductor of heat energy. That's why within an instant when there is a change in temperature, it can measure the change in temperature very quickly. So rapid change in temperature can be measured. Liquid in a glass thermometer can be sensitive. They can have a linear scale, but they cannot measure the temperature rapidly. We have to say it takes like the liquid will take some time to transfer the heat energy. That's why liquid